Well, thank you everybody for joining us today. I'm Jeff Lee. This is Jason Deffenbaugh. We're going to talk about Foundation Medicine's cloud migration and our journey to scale advanced cancer care. Before we get started, we just want to talk about Foundation Medicine just a little bit. We're a genomics insights company. Our focus is on diagnostics to get the right information to patients, providers, as well as researchers, because our goal is to improve cancer care for today, tomorrow, and together.
I work primarily on the genomic analysis infrastructure component, and that's the focus of this talk today, is moving the migration journey of the genomic analysis system from our on-prem data center that we had when we started the company into the cloud.
Right, and I lead the cloud architecture team here at Foundation Medicine. So we're just going to dive right into it. Where were we in 2017 when we first were thinking about moving into the cloud? We were on-prem, super expensive to be on-prem, long lead time, super people intensive, but great for vertical scale. Low latency, sub-millisecond latency, so shared storage was easy. But the business was growing in 2017 quite a bit. New sequencers were coming in with more data to process. New products were being introduced. So more resources, compute, storage, all above. And we're trying to reach more patients with these new products. Also, along with that was the increase in operations. More research was coming in. So dynamic research, unpredictable scale about what they needed to do their new science. The types of technology footprints, the diversity and the patterns were rolling out there with new systems and new applications. That was growing as well. And all of this led to challenges in forecasting what we needed on our on-prem infrastructure, when we needed it, what did we need, and how quickly could we get it. So we decided to move into the cloud. Again, we needed to scale more. The business was growing, and not just as far as the number of products we were rolling out, but also as far as global reach. So like reaching different regions, and also reaching more resources when we needed it. Our workflows in HPC, as Jason was saying, were very bursty. So meaning like you might need only like 0 cores when it's idle, but then you might need thousands of cores when you need to process something quickly. You might only need it for 20 minutes or an hour or just a few minutes. We needed flexibility. As I was saying, the diversity of our technology footprint was growing. So we wanted to be able to have diversity to choose what database type we needed, what kind of compute resources we needed, how much storage. We didn't want to wait forever for it either. But we also want to be cost conscious in moving to the cloud. It's not cheap to move into the cloud, but what the cloud provides you is for you to control your own destiny. So you can cost optimize as much as you'd like in the cloud. All of this was to reduce the time to deliver these new products, remove any barriers. Again, the motto was we wanted what we wanted when we wanted it and as much as we needed of the resources we needed. So I'm going to go through the first phase, what we did. We lift and shifted. What does that mean? We pretty much kept the architecture intact. It was a like-to-like situation. We had NFS on-prem, we had NFS in the cloud. We had HPC clusters running on a bunch of computers, had HPC clusters running a bunch of computers in the cloud. We added tooling to help us orchestrate in the cloud, to help us manage these resources in the cloud, and also to provide an NFS interface. And we also did a very large-scale multi-petabyte data migration, which was not quick because petabytes moving up to the cloud, there's physics involved in doing that. But we did achieve a number of benefits. We did get access to the storage and compute resources we needed, and the lead time to get those resources super quick. We're able to reach more patients, and most importantly, help them. And we were able to increase that flexibility we've been talking about. We might choose this type of database, might choose that type of database, maybe no database at all, maybe more serverless. And another benefit was that it forced us to really Dockerize our applications so that it could be more resilient in mobile. We weren't beholden to having it installed on a computer or EC2 in the cloud. Along with the benefits, there were some pain points in our first phase. The major ones were less fine-grained management of our resources, not just storage. Let's say here, it's just less fine-grained management of resources in the cloud. At the end of the day, you're leveraging cloud services. You don't get the kind of hardware level view of your resources. So there's that piece. Higher latency between different layers, compute and storage or compute in your database. On-prem, as I said, low latency. You have sub-millisecond latency. That round trip between shared storage and your compute is very, very, very cost effective from a time perspective. When you move into the cloud, it might be 10 milliseconds or more. That's 10 to 100 times more in that round trip. So that time gets expensive if you're not optimizing how often you're talking back and forth. And shared file system, again, we had it on-prem, we had it in the cloud when we first moved up there. Difficult to manage, difficult to have that multi-tenancy in the cloud. How we bootstrapped on-prem doesn't necessarily jive with how we bootstrap in the cloud. We went more of a headless bootstrapping in the cloud versus what we were doing on-prem. And the last piece was managing middleware on EC2s in the cloud is a losing battle. EC2s are meant to be ephemeral. If you want to manage middleware on there, you got to monitor it very rigorously. You have to alert yourself because then EC2s can come down and up constantly. Altogether, the lesson learned here is learn the boundaries of the services you're implementing. Understand the expected behaviors because you're not in full control. You need to understand what you're working with and how much you can lean on it. So, as a summary of what I was just saying, we're on-prem, so we had applications we're developing on top of the middleware we had on-prem, and we're managing hardware, middleware, developing applications. Decided we need to scale more. So, no longer managing hardware. We instead moved to cloud managed services to replace the hardware. Still had some middleware in this first phase where we still have to manage it on some EC2s and manage that middleware, but still developing applications on the top. And that takes us to the current phase we're in, which Jason's going to go over, where we are now going to build applications directly into cloud managed services and how we're doing that.
Thanks, Jeff. So this current piece of work that we're doing here, our phase 2, cloud native re-architecture, when we're thinking about what we're going to do, the thing we like to say internally to ourselves is something we call fearless scaling. So we want to not be worried that what our architecture decisions are going to prevent us from scaling horizontally as needed. We're not going to worry about hitting service limits in the middle of the night and there's a problem and somebody has to wake up and click a button. Those are the fears we're trying to be fearless about. So that's like a nice sanity check that we tell ourselves internally as is this a fearless pattern or are we going to have to manage and babysit it? So the way we are tackling this fearless scaling idea is that we can leverage the cloud managed services so we don't have to babysit and maintain middleware. And we can do that with confidence by testing at scale these services and understanding where the limits are of the cloud and how we can best build our applications to fit into that pattern. So the first thing that we had to tackle is storage. As Jeff mentioned, the storage middleware that we moved into the cloud wasn't perfect, no. And that's okay. But the way that we can move forward here, compared to on-prem, is we can leverage cloud managed services like S3 in a different way than we've ever done before. So we changed our pattern to where the scientific compute for like tools that need an NFS-like interface, we are localizing from S3, or the storage is in S3. We can localize, run the normal software that we would always be running, and then persist back into S3. And that each individual task does take a little bit longer. But when you do that in a massively parallel system that's stable, you can actually do more, even though every little thing takes a little bit more time. So that was the storage paradigm. And we've also needed to think about the scalability of our system itself, not just the cloud services, but our own system as well. So one of the problems that we're tackling is networking. We need to make sure that we can get access to the number of IPs we need. And also another problem is AWS account limits. So if we can horizontally scale in AWS accounts, each account limit is then spread out amongst all the different accounts.
So that, again, I think the key things that we're trying to espouse here is rethinking the problem, rethinking your systems. And that's what we had to do, like turn the solution to say, yes, we might still need POSIX and NFS, but does it have to be like a centralized NFS? No, we could have back it by S3, localize it, and use NFS and POSIX as we originally planned to use it. So both of those things are about turning the problem on its head and seeing, again, the boundaries of the services that we wanted to use and how do we use it at the scale we need to use it.
And then once we do that, what you can't just turn stuff on in the cloud and assume it's going to work for forever. You need to observe what's going on, understand how you're using the services, because sometimes AWS services will leverage other AWS services, and where are those edges. So that's what the observability part is that we're building into our system as well.
And again, along the lines of that is being able to observe what problem we're trying to solve for. As Jason was saying, there's persistent parts and then there's ephemeral parts, elastic parts. So if we observe that, hey, this pattern is a lot more elastic and would be better suited to just decouple that from the persistent parts that is not super scalable in the way we want it to be, you only kind of get that if you start measuring and observing more and more. So
at the end of the day here, we've rebuilt our systems to use cloud native POSIX-like file systems so that researchers can continue to use the tools they like without having to change what they're doing, and it's sort of invisible to them, but we're not managing a middleware layer to provide that to them. We've rebuilt our network using Transit Gateway and other AWS tools that let us get out of the middle management of how the network is wired together. And then the other thing that we're working on currently is continuing to take the code, the software, make it so that it's not married to the persistent state of our system, so that we can respin the software from scratch, start over, but we haven't lost any of our persistent state. So that's something that we're working on now. And as Jeff mentioned at the beginning, we did build our web applications and like operational software and containers so that it's easy to deploy in AWS. But the next thing that we need to do is work on containerizing the scientific code base as well, which is something they're not used to using containers. And so it's a bit of a different lift for us, but it's something I think we can achieve. And we've got ideas on how to make that happen. That's going on right now. The summary of our move to the cloud is that there were challenges. Storage specifically was a big challenge. You don't have the distributed disk like wired in with each other so that they're sitting like literally centimeters away from the other disks. That's a total different experience.
It's pricey. So
right.
Again, cost effectiveness is one thing. As I said, moving to the cloud initially, it's not that it's cheaper, it's that you get more controls with AWS services on how you manage that cost. So tuning cost is key, especially when you have petabytes of data sitting in the cloud.
So distributing scientific code and references is a challenge as well. How do we get research code to the computers that need to run it without the researchers having a difficult experience? Was a challenge. I think we have a solution that works clearly, but I think we can improve that as time goes forward. So actually, there were opportunities too, as well as challenges. One opportunity that I was actually really impressed with was AWS's response to some of the needs we had. So in order to get off our middleware layer managing our compute cluster, we've worked with them, with the AWS batch team, for example, to talk about enhancements to that system, thinking about priority and scale down behavior to reduce our cost. And that's been a great experience working with those teams to really enhance the AWS services so that we can get our use cases finished and completed. Another thing, a good experience for us, was understanding the opportunity to learn about how cloud services work and where the boundaries are so that we can create an architecture that works within those boundaries and then is scalable to be horizontally scalable, so we can just repeat that pattern over and over again, is a way to add total scale without needing to have one service be responsible for physics that it can't handle, basically. So that's been, and I think our architecture actually ended up in a better place after we did all that.
Absolutely. The decoupling that was necessary in order to work with the cloud services, it further enhanced the resiliency as well as, we say, the fearlessness. What we didn't want to be awoken at nights. We didn't want to be scared about these things. And that re-architecture furthered our systems architecture as far as how resilient we are. And now we can help patients more. There's not just the patients we're helping now, but globally, because now we can go to more regions and such. So lots of benefits there.
The best outcome I think we had is the reduced time to deliver new products, and that means not just how we can deploy products that are ready for production, but it's also how do we do the R&D to build those products from scratch. Anytime we're building a new lab assay or a new genomic analysis algorithm, both of those situations require compute to analyze the sequencing data or to test and fail and test and then eventually succeed at the new software algorithm. So when people are waiting for their experiments to finish, that's a big delay, because just like any software developer, if you can reduce the feedback loop on your own test to understand if you were successful or not, then that can snowball into a much faster outcome. And I think the scale that we did for both production and research use cases has really helped empower Foundation Medicine to deliver new products.
Absolutely, yeah. Moving to AWS and our re-architecture helps us make technology problems without having to impact the scientific problems that our researchers are trying to solve. Cancer's hard. It's a lot of unknowns. So why would we make it even harder by putting technology problems front and center so they have to deal with it?
So what's next? Where do we go from here? Data is again on this slide, and that's because it's not trivial, like we've been saying. Now that we have data in the cloud and we're building more and more, or we're persisting more and more data all the time, one of the problems we have is the metadata about that data. So how do we know what storage tier we want it in? How do we get it into the right place at the right time by tracking, just data about the data is really what I mean. Like what's available for researchers to access, for example.
Yeah, it helps by improving the management of the data we're storing. It helps researchers, it helps our business, it helps our patients, it helps all of us to figure out what data we need to get when we need to get it to where. So that's all part of the management of the growing data set we've got going on.
We've built our architecture to be regional deployable, and that is already in production today. Mm-hmm. But the other thing that we need to do is we can continue that expansion to multiple regions around the world to support Foundation Medicine's business, but also just to continue to actually help with the next bullet, which is looking for cost optimizations. And that's not only in our infrastructure, but that's in our scientific code base. We can look to cost optimize as well by being clever about the algorithms we're writing. We want to operate the system. I think we can improve our operational experience as well, because people today although we have a lot of automation, we do have to, it is a bit of a manual process to build new accounts and to get some deployments out there. So we're looking to reduce that with even more automation and observing it even better. And then finally, we still need to enhance the research experience for storage. That's a big question for us is what the actual research storage looks like. I think we have a lot of ideas, but we need to finish implementing that experience so that people can feel like they don't have to know about the cloud to access the data. That's something we can enhance.
Absolutely. All of these, where we go from here are meant for continuous improvement in the cloud. As AWS services evolve and new features come out, it's keeping an eye on the pulse of those services and working with AWS to understand what, again, the boundaries of those improvements are. So we can continuously improve how we do what we do in the cloud so that the business and the scientific community can tackle what they're trying to tackle there too. And again, one of the main ways to do that is